video, we're going to go over factoring. As you can see, there's multiple different types of factoring. So your job is to look at the problem and decide which one to do. Now the first one, you always want to do first, which is called the greatest common factor. No matter what type of factoring you're doing, always look for a greatest common factor first. And that's something that all of the terms have in common. So if we are given this and we're asked to factor it, we want to find what they have in common. So if we have a 6 and a 9, the number that they both have in common, the biggest factor that they have in common would be a 3. So we'll take out a 3. Then we look at our x's. We have x to the third and x squared. So we can take out x squared from both of them. And then we look at our y's and we can take out a y from both. So you always take out the greatest common factor first. You leave that out front. And then you write what's left over. So if I take a 3 out of a 6 and I divide that, that would be left with a 2. If I had 3 x's and I take 2 away, then I would be left with just 1 x here. And I had 1 y and I took 1 y out, so there's no y left in that first term. Now we do the same thing with the second term. 9 divided by 3 would be 3. We had x squared and we took x squared out, so we don't have any x's left. But we had 2 y's here, y squared, and we took 1 out, so there would be 1 y left here. So that would be the factored form of this problem. The next type of factoring is grouping, and you do that whenever you have 4 terms. Now again, you still want to see if there's something that all of these have in common, which there's not, so there's no greatest common factor, so we can just start grouping. So when you group, you take, put parentheses around the first 2 and around the second 2 to group them. And then we're going to use what we did up here and just take the GCF out of each of these parentheses. So out of these 2, what they both have in common would be a 3n squared. And what's left when I take a 3n squared out would be 2n plus 1. And then we do the same thing here. You find the greatest common factor of these 2, which would be a 4. And that would be a positive 4. And when I take a 4 out here, I would be left with 2n plus 1. Now we're not done yet, but this is where you want to check yourself. If you have these, that they're the same, then most likely do this right, because these have to be the same thing when you do factor by grouping. If these are not the same, then you want to go back and check your work. So once you have, you take these out and you see that these are the same, we can actually write our final answer, which is 1 is just what you have on the outside. So that would be 3n squared plus 4. And then the other factor is what you had on the inside of your parentheses, so that would be 2n plus 1. And that will be the final answer for this. Lastly, we're going to look at a trinomial, which trinomial is 3 terms. So again, we always look for the greatest common factor. This doesn't have one, so we can start the process. So what you do with a trinomial is you multiply the first term times the last term, so a times c, and you would get 18. So you're looking for 2 numbers that multiply to 18 and add to the middle term, which is 11. So you go through the factors of 18 until you find ones that add to 11, which would be 2 and 9. So 2. Once you have these 2 terms here, we're going to rewrite them in the middle. So instead of 11x, we're going to write 2x and 9x. So we keep our first term. We rewrite the middle with our new 2 terms, and then we keep the last. So as you see, we didn't change the problem, we just expanded this 11 to 2x and 9x. Because now that we did this, we can use what we did up here, and we could do grouping. So again, parentheses, take out the GCF of the first 2, so that would be 2x, 3x plus 1. Take out the greatest common factor of the second 2, which would just be a 3. Again, we're going to check that these are the same, which they are, so we're in good shape. And then when you write your final answer, 1 is what's on the outside, so 2x plus 3. And the other is what's on the inside, 3x plus 1. And whenever you do factoring, again, what you're doing is you're taking apart a problem. So to check that it's right, if you go back with any of these problems and you multiply it back out, you should get what you started with. So you always want to check your work. So if I multiply these, I would get my original problem. If I multiply these 2 things, I would get my original problem. Same thing up here. If I distributed, I would get my original problem. There you go.